Okay, so number 5, we should be pretty good at doing our row operations by now. It's just sort of right at the end of it that I'm hoping that you need the help with. Well, hoping that you don't. But anyway, so for this one, we've written our coefficients in, again being really careful with how we put it in, double checking that you've got the right positives and negatives around the place. And we want to make sure that we've got zeros going on here. So to make a 0 in our first place, we're going to say 2 lots of row 1 take row 2. I've done it to the side here, so we get 0, minus 2 take, we get 1, 6 take 1 is 7, and 2 take 3 is minus 1. All right, notice that we've got a k in this one. So now to get a 0 in this position, we say 3 row 1, take row 3, 0, 2, 9, take, ooh, what's that, 14, and then 3 take k. So we've got 2, 14, 3 take k. And now we want to have a 0 in this position. All right, so we get our 0, and to get a 0 here, we're going to say 2 times. All right, 2 times that minus row 3. So 0 take 0, 2 take 2 is 0, 14 take 14, 0. Be careful here, it's minus 2 minus 3 take k. So minus makes a plus. So I'm going to end up with k minus 2 take 3 is minus 5. Okay? And this is where we have to consider when we've got our bottom row, when it's 0, 0, 0, 0, right? What happens then? As opposed to when it's 0, 0, something, right? And we're saying A isn't equal to 0, what happens now? We know this one, that when we have 0z equals, let's say, 4, that's impossible because 0 times anything gives me 0. So for this, what we'll be saying is when k doesn't equal 5, right? So it can be any other number apart from 5. So if it's 10, 10 take 5 is 5, 1 take 5 is minus 4. You're going to get this situation here where we have no solution. Now we look back and we suss, right? None of these equations are parallel, okay? So if I times all of this by 2, I don't get this, right? I get 2 there, but then I don't get a 2 here. So these two aren't parallel. And what if I times everything here by 3? Nope. So none of them are parallel. And yet we've got this no solution, which tells us that we've got this situation going on where we've got they're intersecting at various lines and we don't find those solutions. Okay, because it's not one solution, it's all over the shop. All right. Now, however, when k does equal 5, what happens is we've got this situation going on here. Okay, and that's when we give our infinitely many solutions. Okay, and again, what situation is that going to be? We've got non-parallel planes. So they're not parallel, but they will meet in a common line. So it's this one here with 7. Okay, so let's get our solutions here. So we're going to have to say let z equal t. Therefore, we've got y equals minus 1 take 7z. So in other words, y equals minus 1 take 7t. And to get x is 1 take 3z plus y. So 1 take 3t plus minus 1 take 7t. Sounded like I said 70 then, didn't it? 1 minus 1 gone, minus 3 take, so we get minus 10t. So this is the equation, of our common line where the 3 planes intersect. Better just write that down. So 3 planes intersect at, or we should say along, a common line. Done.